All right, so today we're going to start off with 3.2. So surface area.
Do you draw this?
Yeah, young man, can you please sit down? Thank you.
Do you write high pals?
Can you sit down, please?
I'll sit down. High pals.
Okay, guys, so here we go. Surface area, pyramids, cylinders, spheres, and cones. Aaron, put that thing away, buddy. All right. All right, so what's it going to start off with? Review, working with circles. Okay, so say you had a circular region.
What page is that?
If you put a fence around a circle, what do you call that? Yeah, perimeter. What's perimeter of a circle? Circumference, right there, yeah. So circumference. So scan your yellow document on the back page. Where's the circumference formula? You have two choices. Circumference is 2 pi times the radius, or circumference is pi times the diameter. So you have two choices. And both of those are on your yellow sheet. And say you wanted to put grass into this circle. What do you call that? Area. And the area of a circle formula is pi times the radius times the radius. So just times the radius by itself 2 times, so pi r square. So those should be familiar to you. And what is a radius? From the middle to the edge is a radius. Okay? Diameter. Good question. Whole line through is the diameter. It's got to go from the through the middle though. Through the middle is the diameter. All right, those formulas. Oh, they're doing this question here, and what all they do for this question is they kind of like a hockey rink. You just draw these lines like that, and it breaks it into 2 sections. You have a rectangle, and then you have 2 half circles. What does 2 half circles make? A full circle. So that's all they got here. Area of a rectangle, area of a circle. What do they do after at the end? Add them up. So the total area is just the area, the 2 regions. So that stuff we did last section as well. Just different shapes now. Okay? So this what do you call this? Looks like a door almost, sideways door. Or sort of like a design you'd have on like a window maybe. Well, sometimes doors have that shape if it's rotated. Sometimes.
You ever seen the circle door? That's the thing from Mario.
Yeah, like from Mario. Oh, the bullet.
Yeah, that's what I'm saying.
The bullet Bob or whatever it is. Bullet Bill. Yeah.
Oh yeah, yeah.
All right. So where would I draw a line here, guys? I need to section this off into 2 shapes. So where should I draw a line? Make not a square, but a rectangle and a half circle. Looks like a square, but it's really close. See 3.25 and 3.5? Yeah, it's 0.25 off of being a square. Good observations. Times what by 2? I think we would divide by 2. Is that what you're thinking? Right there. So why did I divide by 2, guys? Because it's a half circle. Good. Half circle. So take your normal formula and then divide by 2. Come on, focus, man. Come on. Guys, too much chatter right now, okay? Yeah, grade 8. All right. So first of all, what is the radius of this circle? Does it have to go halfway from the center? So what is this distance here? What would it be half of? It would be half of this 3.5. Okay? So the radius will be the diameter divided by 2. So in this case, 3.5 divided by 2. I think that's 1.75. Okay, so now we can do our area circle or half circle calculation. So 1.75 squared divided by 2 times by pi.
How come you don't put pi and the 1.75 together?
Because you have to square the 1.75 first. So it's like order of operations. So do the square first. So you can go 1.75 times 1.75, or you could use the exponent button. Doesn't really matter. But make sure you use the pi button, okay? Because everyone's going to get different answers if you don't. And I'll just round to a couple decimals here. And remember, the units are always square units. So this is square feet. Alright, now let's do the area of this rectangle. That's just length times width. So you just times these two together. And then all you gotta do, guys, is add them up. Okay? Add up these two final areas. Okay, I got 16.185, and this will be square feet. How come you don't take notes, man?
I learn better. Just watch.
Well, take a little bit of notes. It's not going to hurt you. Does anybody still need that? Okay. So if you're already done, take a look at the next question. Decide where you're going to draw some lines for the problem solving. You can put that on my desk or what? No. Yeah. All right. Next question. We good? All right. So where are we going to draw the lines for this for problem solving? Okay, I heard somebody's got it. Anybody else want to offer it up? Exactly. What is that? So you got to make it into shapes that are more familiar to you. So where would you draw the line? Half circle and a triangle. Pyramids are 3D, right? So it's not a pyramid. All good. So we have area of this half circle, and we need area, whoops, area of this triangle. Alright. It does give you the diameter. So what do we do with diameters?
How's that the diameter?
Because it's the if it was a full circle, it would be the whole way across. Does everybody see that?
I don't get it. It's going across.
Uh-oh. We're having some... Holy... Something's going wrong here. Sorry, let me just reload this. Sorry, this thing's screwing up. Okay, there we go. Okay, sorry, my thing had like a mental breakdown here. Okay, project. Alright, so we're back at it here. So we drew this line there. We got a half circle. Area of a half circle. So pi r square, we're going to divide that by 2. They gave us the diameter, 6.8, so divide that by 2 to get the radius. 3.4, good. So in our formula, we'll take 3.4, we'll square it, and then we'll times by pi, divide by 2. Remember bed mass, order of operations? If you're borrowing my calculator, you could just type it in exactly how you see it, and everything's going to work out for you. Because the calculator's no order of operations if you use one of mine. So this is like 18.158 square centimeters. Now we just got to do the triangle. So what's the formula for a triangle? Area? Base times height dividing 2. So what's the base of the triangle? Is it the diameter of the circle? It would have to be, right? Because it goes through the center of the circle and reaches the edges. Does everybody see that? Here's the center, everybody see it? And then it goes to the edges, one full line. That's the base of the triangle. It's identical to the diameter of the circle. So 6.8 for the base. And the height is always 90 degrees to the base. So this height, that's equivalent to the radius of the circle. So that would be 3.4. Divide that by 2. Got 11.56. Add up the two areas. Add up those two areas and you have the total area of the weird shape. So area total is the sum. It's going to be 29.718 square centimeters. Alright, so that's not too bad. Let's take a look at number 3. What's weird about number 3? There's an indent. So would you add areas or would you subtract areas? Good. You guys seem to know this kind of stuff. Did you need that page? You know, I always see most of the people taking notes, which is good to see, but then when it comes time to like the quiz or the homework, sometimes I see you guys not using your notes. So remember, there's a reason why we take the notes. It's just, I mean, it's not for fun. Okay, we use the notes so they're going to help us later. Okay? You okay? Alright, so what shapes do we have for number 3? What shapes do we have for number 3, guys? Half circle and a rectangle? Alright, so if you were to calculate the area of the rectangle, so draw this line in here. Draw that line. And this area would cover, when you multiply the length and the width, this is going to give you the area of the total rectangle, okay? Now what we want to do is, like you guys said, it's like indent it out or subtract it out. Not necessarily 90, but what? The area of a half circle you'd have to take out. So area of a half circle, we already know how to do those. Pi r squared divided by 2. And my friend, what's the radius in this case? Would be, if that distance is 90, divide by 2, good to get. Very nice. Very nice. So pi times 45 power 2 divide by 2. So ladies and gentlemen, if you just type exactly like that into your calculator, if you use one of mine, it's going to work out perfectly every time. Okay? So no issues. Make sure you use the pi button or else it's going to be like, people are going to be like, what'd you get? Why is it so much different than mine? But it's just going to be off a little bit. So just use the pi button. Alright, so there's to a couple decimals. Now what do I do with these two areas? This area here and this area here. What do I do with them? Add them or subtract them? subtract. And which one goes first, a big number or a small number? Big. So 77,500, take away 3,180. What are you going to get? $74319 millimeters square. Okay, for the man that doesn't take notes, can you explain little 2? What is this?
What?
The thing I'm pointing at. What is little 2 here? What does this stand for? Little 2. What does this stand for? But what kind of millimeter? Yes, a square millimeter. Okay, area is always measured in a square unit. That's what this little 2 means. You're going to get deducted points if you don't use the proper units. Does everybody hear that? So no, I don't want to hear anybody complaining about losing marks for proper units. I'm telling you right now. Because it tells me your level of understanding. Like when you go into a hardware store like Home Depot and you go, yeah, can I get 30 feet of flooring? They're going to be like, what? What do you mean 30 feet? That's a linear measurement. That's how you'd measure a straight line. No, you would need 30 square feet. Okay? So. Alright, here's the next shape. What's the next shape on the page here, guys? Cylinder. What are some common uses of the cylinder? Can of pop, right? Alright. What about a can of soup? Imagine you had a can of soup. Okay, this is my can of soup. Okay. What do you notice that goes around the curved part? A label. A label. Mr. Christian, do you need to put that on my desk? This thing here wraps around the soup can. It'd be perfect. How would it wrap around the soup can? What is this? A circumference of the circle would be the length of the rectangle. Does everybody see that? So you wrap it around, there's your circle. Okay. And then you times it by the height. You get the circumference times the height of the... Uh-oh. Oh, it's in my pocket. Sorry. Alright, so here we go. Surface area of a cylinder. All it's going to be is the label of a soup can plus 2 circles. Can everybody just jot that in? The label is just a rectangle. If you were to unfold it, okay? And the circumference of the label, C, will be exactly the length of the rectangle. Okay, so length, it's basically just going to be length times width there. Yep, circumference. Yep.
This is the circumference of
Did you need that? Okay, so let me jot down the formula for you on this page. So surface area of a cylinder, and this is on your yellow sheet. Okay. So let's start with the 2 circles. 2 circles would look like this.
I will pick it up for you.
No. There's 2 circles. 2 pi r square. Anybody know how we're going to get the formula for the rectangle? Remember, it's related to the circumference. So for the rectangle, to get this area, you have to times this length by this height. And the length is just the circumference, so 2 pi r. And the width is the height of the cylinder, so right like that. So that's the formula for the cylinder. And it is on your yellow sheet if you still have that. Hopefully you still do. Okay, I can print some more, but that yellow sheet is your golden ticket. Alright, so there's an example where it's done for you. So here, I'll just do one from scratch on number 4. So if you see something like this, especially guys at ESL, okay, see this word? Cylindrical. So think cylinder, okay? So just got to pick out the keywords, surface area, because like later we're going to be doing volume, so make sure you can pick out the keywords. Here's radius and here's height, okay? So you'd read surface area cylinder, so you're going to jot this down like surface area is 2 pi r square plus 2 pi r h. That just comes straight from the formula sheet, okay? You guys know where to find it on the back of that formula sheet? Right? You guys have all probably used these before, okay? On the back of the formula sheet. Okay, so this one, if you have a nice calculator, is easy breezy, okay? You wouldn't have to do anything special. You just have to type it in just like you see it here. You don't have to do steps, you don't have to do anything crazy. You just type it in exactly like that. Don't forget the square button, okay, on the 1.5. And this is going to do it perfectly for you. So I'm getting 61. I'll round up 61.3, and it'll be square meter for the cylinder. Alright, so here's the next one, surface area of a pipe. Alright, so see how they give you diameter? This is very common, so always just like divide by 2.
Do you need to divide by 2 if only if you need the diameter?
Always, if they give you diameter, always just divide by 2. So you get 2.25.
Why would you divide it by 2 if you can just times it by 4.5?
Because you need a radius for the formula, not a diameter. And this 18.8 centimeters long is like the height of the cylinder, okay?
Just times it by 2 at the end of the day.
It won't work like that, man.
So if you just had 4.5, you just times it not by 2.
You have to divide it, sir.
Try it out.
No.
Here, look.
I'm too smart for that, man.
Do it on the calculator.
Alright, you do that. Okay, 2 pi r squared plus 2 pi rh. Mustafa, you're too much, man. Starting to drive me crazy.
I'm going to show you something.
You're not going to show me anything except that you're wrong.
What? I'm going to show you something. I'm trying to teach the teacher. You know what I mean?
Nah.
Why not?
Sir, just let it go.
Next time.
Next time.
Tomorrow.
You're insane, man. You get too bored because you're not taking notes and then you want to act out. So if you just took notes, you wouldn't want to act out.
I have a game after this. I just break my fingers.
Alright. Alright, so I didn't really show you the second step, guys, but because it's identical to above, you just type in the 2.25 for the radius squared, and you type in 18.8 for the h, and you'll be okay. Alright, so here is where it gets really ridiculous. Okay? So, like, just to be clear, these types of questions, if they ask for the surface area, see I highlighted it for you, you're only interested in faces. You know what a face is? Like a face of a shape? So only the faces on the surface. So it's not much of a explanation. But for example, there's a circle at the bottom of this cylinder that is not on the surface. So you would have to omit that face from your calculation. That's question. After this question. So that's why you have to know. That's why you have to know what these symbols represent on your formula sheet. So if everyone has their formula sheet, what you can do is circle this and put 2 circles, and circle this and put the label that goes around the soup can or whatever. Because when you go to do the surface area calculation of the cylinder on top, you would have to change this 2 to a 1. Does anybody know why? Because there's only one circle on the surface. The other one is being omitted, right? Okay, so for the top cylinder, I'll put surface area 1. For this shape here, surface area 1, you will have to go with pi r squared plus 2 pi r h, because one of the circles was omitted. And this is the kind of stuff that makes this test hard. Like, any one of us could just plug into the formula if they give us the right stuff. But this is the kind of stuff that makes it more challenging, in the sense that you got to problem solve your way and use these symbols properly, okay? So really take good notes this unit. A lot of your marks will be boosted after chapter 2, which is good. This is chapter 3 now. Alright, so plugging away here, pi times 3.8 squared plus 2 pi 3.8 and 9.6. Okay, so 274.58 after rounding. Question? Sure. Or can you wait like 2 minutes? Yeah, wait like 2 minutes. Okay, so there's the first cylinder with one of the faces omitted. Okay? Now for the second cylinder. Now for the second cylinder, everything's normal except for the top face. And what's weird about the top face is that some of the circle's been removed. Can you see that? Right, some of this circle. So for the top face, you have to do a funny little calculation. Okay. So for the bottom cylinder, cylinder 2, I'm gonna just calculate everything as if there's nothing on top. So there's the bottom circle plus the label. Okay. Plus the top, which I'll get to. Is everybody okay with that? I'm going to do the bottom circle. I'm going to do the label. And then I'll do the top at the end, because the top's really weird. Okay? All right. Okay, so for the bottom circle, the radius is, anybody got this? This is gonna, you gotta do a little bit of problem solving. How you gonna get this radius? A portion of it is 4.2, and another portion of it is 3.8. So add those up, 3.8 and 4.2, you get 8. So the radius is 8 millimeters. So pi times 8 squared plus 2 pi 8, and the height is 4.8, plus the top, which I will get to. Question? So see this distance, this red distance, 8? You get it from this one here, and this right here. You add those up. This distance and this distance added up is 8. See it? All right. All right, so here we go. Typing into my calculator these numbers. I got 442.34 after rounding plus the top. Alright, so now I gotta figure out the top. Alright, so how are we gonna do the top? Yeah, so there's this big circle, and then you have to omit the bottom circle in black there. So you need to do 2 calculations and subtract them. So it's going to be pi 8 squared minus pi 3.8 squared. Okay, this is the radius of the large circle. This is the radius of the small circle. So when you calculate this, you get 155.7 after rounding. Add that to that other 442, and you get the total area of this thing that kind of looks like a wedding cake. So it looks like 598, and the unit is millimeters square. Okay, so that's a tiny little wedding cake. Alright, so let's flip ahead to the first part of the homework. And let's try that question right now. So number 1 on page 167. Just got one question for you to do here. We're not skipping the book. It's just a huge section, and we're going to chunk away at the homework. So this question here, everybody's going to try it right now. Is it page 167? Okay, so everybody's going to try this one now. Okay. Okay, so we're finished with this homework question. So put your phones away. Neither, you shouldn't have that thing out at all. Back it up to where we left off. And alright, so here we are. We're on page 154. So get to this page. There's only about 10 minutes left, guys, so I'm just going to continue on with some more notes. So page 154. Everybody's with me? Page 154. 154 has got to back up a few pages, okay? What is the meaning of this?
Stealing my...
No. You put those away, Aaron, before someone steals them.
That's how it's done.
Okay. What's this? You want to calculate this? like length times width, and then add them all up. Alright, so let's go on to the next section. Looks like pyramids. No, sir. Don't tell me what to do.
Please.
Alright, so...
I'll start taking notes.
Alright. Okay. So here's a pyramid. Does everybody know what a pyramid is? Think about Egypt. Right? Alright, so for a pyramid, the base can be any shape, but typically it's a square or a rectangle. And typically it's a square. That's a cone, but yeah. It could be a circle pyramid for sure. And the faces reach this place called an apex. Okay. So let me help you draw a pyramid, okay? So what you have to do is draw a square, sort of slanted. Does everybody see that? You have to practice this, guys. Draw a slanted square like this, but it's not quite a diamond because it's off center. You draw a dot in the center of the face. Draw a dotted line up into the air. This is going to give the observer some perspective. And then you connect the apex to the edges. The apex is the point that all these triangles meet at. Okay? And that gives the impression of 3D. Okay, it's not entirely easy to do the first time you try it, so... No. That's only for trig. Alright, so let's take a look at how they calculate the surface area of this pyramid. Okay, so first of all, what do? They calculate the area of the base, which is a square. So side squared, 24 times 24. These notes don't make any sense. I think this should say 24 squared like that. So check your paper. I think there's a typo there. The book has a little typo there, so fix that. And then it says to calculate the area of one of the side triangles. Because if you knew the area of one of them, what could you do to it? Add it up or times by 4, because there's 4 triangles. Okay? And I believe they do that on the next page. Calculating the total surface area, it's the square plus the 4 triangles. Okay, so I'll write that in here. Square plus 4 triangles. Okay? So here we go. Let's take a look at number 7. Relax. Okay, so for this pyramid, the surface area formula would be the area of a square plus the area of 4 triangles. Okay? Is everybody okay with that? So the square is the base, and then there's 4 triangles that meet at the apex. Everybody see that? Alright, so what's the area of a square? Just 28 times 28. Or you could write it like 28 squared, but it doesn't really matter. Just length times width that are the same. You get 784 for that part. Now the 4 triangles. Okay. Do you guys see on your formula sheet this shape? Base height like this. And then on the formula sheet it says base height divided by 2. Everybody see that on their formula sheet? It's at the top. Okay. So what's the base and height of one of these triangles? It's this guy. There's the triangle. Its height is 21 and its base is 28. Okay. So 21 times 28 divided by 2. I got 294. That's the area of one triangle. So I'm going to come put this up here. 294 times 4 because there is 4 of them. So 1176. Adding these up. 1960 square centimeter. How did that feel? What time is it? Turn it back on.
Why?
Turn it back on, see the time.
9. Why isn't that working?
3:22. Okay. So we got a few more minutes left. Okay, for the next question, can you guys just cross it out? I don't plan on doing any questions that aren't familiar shapes. So I don't care about the pentagon. I'm just going to do squares, rectangles, circles, and triangles, okay? So let's just do, yeah, we can cross out 9 as well, because it's octagonal. Okay, I don't care about that. It's an octagon. Octagonal. Okay, so this is where we'll start off tomorrow. Okay, example 4. And you'll have to use Pythagorean theorems, so. Alright, so that's it for today. There's a few minutes left. Stay in your desks. It's supposed to be 106. I'll come back.